Problem 1. Andy and Betsy both live in Mathville. Andy leaves Mathville on his bicycle at 1:30, traveling due north at a steady 8 miles per hour. Betsy leaves on her bicycle from the same point at 2:30, traveling due east at a steady 12 miles per hour. At what time will they be exactly the same distance from their common starting point? So say this is their common starting point. Andy is moving north at 8 miles per hour, and Betsy is moving east at 12 miles per hour. So say that they're the same distance apart X hours after 1:30. Then from the problem, we know that Andy has traveled 8 times X miles, and this should be the same distance that Betsy travels, which is 12 times X minus 1 miles, since Betsy leaves an hour after Andy and thus has an hour less of traveling time. So if we just expand this, we should get 4x equals 12, which means that x equals 3. Since we define x to be hours after 1:30, the time that they're the same distance from their common starting point should be 4:30. So the answer is E. Problem 2. A box contains 10 pounds of a nut mix that is 50% peanuts, 20% cashews, and 30% almonds. A second nut mix containing 20% peanuts, 40% cashews, and 40% almonds is added to the box, resulting in a new nut mix that is 40% peanuts. How many pounds of cashews are now in the box? So first, the problem gives us information about the amount of peanuts that we have collectively that can help us find how big the second nut mix is, since we don't know that. So let's write that equation. So first, we know in the first box we have 10 times 50% peanuts, and in the second box we have x. Let's say that the second box has x pounds of nuts total. Then in the second box we have x times 40%, or x times 20% peanuts. So on the left side here we have the total number of peanuts, and that should be the same as 40% of both boxes combined, as the problem tells us. So now we can just solve for x. So 5 plus 1/5 x equals 4 plus 2/5 x, meaning that 1/5 x equals 1, so x equals 5. So now we know that our second nut mix has 5 pounds of nuts total. Now we can answer the question, which is how many pounds of cashews are in the box. We know that in the first box there's 10 times 20% cashews, and in the second box there's 5 times 40% cashews. So the answer should be 2 plus 2, which equals 4, or B. Problem 3. A team of students is going to compete against a team of teachers in a trivia contest. The total number of students and teachers is 15. Ash, a cousin of one of the students, wants to join the contest. If Ash plays with the students, the average age on that team will increase from 12 to 14. If Ash plays with the teachers, the average age on that team will decrease from 55 to 52. How old is Ash? First, let's say that the total number of students is represented by the variable A, and the total number of teachers is represented by the variable B. Then we can write A plus B equals 15. And let's say that the sum of the ages of the students, sum of the ages of the students is going to be SA. And similarly, we also have SB to represent the sum of the ages of the teachers. Then we can write that SA over A equals 12 and SA plus X, which is Ash's age, over A plus 1 equals 14. These two equations come from the fact that the average age on the team will increase from 12 to 14 if Ash joins the students. And similarly, we can write SB over B equals 55 and SB plus X over B plus 1 equals 52 from the condition that if Ash plays with the teachers, the average age on that team will decrease from 55 to 52. Now we can just go ahead and expand the equations, try to substitute out the SA and the SB, and also substitute either A or B out so that we only have an equation about A or only an equation about B that will let us solve for that variable. So let's expand, which gives us SA equals 12A, SA plus X equals 14A plus 14, SB equals 55B, and SB plus X equals 52B plus 52. So we can substitute in SA and substitute in SB to get 12A plus X equals 14A plus 14, as well as 55B plus X equals 52B plus 52. So if we just isolate X on one side in both of these equations, we'll get X equals 2A plus 14 and X equals 52 minus 3B. Keep in mind that we ultimately want to find X, which is Ash's age. And to do this, we can first solve for A or solve for B and plug back into one of these equations. So recall that A plus B equals 15. So we can say that A equals 15 minus B. So if we set these equations equal, we should get 2A plus 14 equals 52 minus 3B. And then if we plug in A, we can get an equation that only involves B. So solving for this will give B equals 8. So now we can plug this value back into this equation to get X. That is, X equals 52 minus 3 times B, which equals 52 minus 24, which equals 28. So our final answer should be A, that Ash is 28 years old. Problem 4. Agnes writes the following 4 statements on a blank piece of paper. At least one of these statements is true. At least 2 of these statements are true. At least 2 of these statements are false. At least one of these statements is false. Each statement is either true or false. How many false statements did Agnes write on the paper? So this problem can get pretty confusing pretty quickly just because all of the trues and falses all over the place. So we can just approach this problem very systematically and in an organized way so that we don't get confused. So we can just test all the combinations of whether the statements are true and false. For example, first we can test to see if it's possible that each statement in order is true, 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 and true. So let's just go ahead and see if that's possible. Is it true that at least one of these statements is true? Yes. Is it true that at least 2 of these statements are true? Yeah, we have 4. Is it true that at least two of these statements are false? No, because we don't have any false statements. So that means that Agnes could not have written a true, 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 and true statement in that order. So let's move on to the next set of possibilities, which is that Agnes wrote 3 true statements and 1 false statement. There's 4 ways that she could have done that. She could have done true, 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 false, true, true, false, true, true, false, true, true, and false, true, true, true. Again, these symbols mean that the first statement is true, the second statement is true, the third statement is true, the fourth statement is false, etc. So let's go through these as well and see if any of them are possible. Is it true that at least one of these statements is true? Yes. Is it true that at least 2 of these statements are true? Yes. There's 3. Is it true that at least 2 of these statements are false? No, because we only have 1 false statement. So Agnes could not have written a true, 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 and false statement in that order. Let's try the next possibility. Is it true that at least one of these statements is true? Yes, because there's 3 true statements. Is it true that at least 2 of these statements are true? Again, yes. Is it false that at least 2 of these statements are false? That's correct, because we only have 1 false statement. Is it true that at least one of these statements is false? Yes, we have 1 false statement. So as we can see, this combination works. Agnes could in fact have written a true, a false, and then a true statement in that order. And in this situation, Agnes wrote 1 false statement. So we can confidently say that the answer is 1 or B.